This is A Radhika. I'm going to uh, I'm going to discuss about the power electronics subject. This is for fifth semester electrical students. In last class, we discussed about the commutation and class A commutation. Today, I'm going to discuss about the class B commutation. So in previous class, we discussed the commutation techniques, types of commutation techniques, and the working of class A commutation. So here today we are going to discuss about the working of class B commutation. So in this class B commutation, this type of commutation is achieved by using LC circuit elements. In this, the capacitor C charges as positive at the upper plate. So here in this, class B commutation is self-commutated by an LC circuit. The capacitor C charges up in the dot as positive before a gate pulse is applied to the SCR. When SCR is triggered, the resulting current has two components. So the constant load current I load flows through RL load. This is the diagram for class B commutation. In this type of commutation is achieving by using LC circuit. In this, the capacitance C charges as positive at the upper plate and and the gate pulse is applied to the SCR. When the SCR is triggered, the resulting current has two components. The constant current I load flows through RL. So here the load current So in this class B self commutation, this type of commutation is achieved by using LC circuit elements. So in this, the capacitor C charges as positive at the upper plate. So here, upper plate of the capacitor. So before a gate pulse is applied to the SCR, when the SCR is triggered, the resulting current has two components. The constant current I means load current flows through RL circuit. So the load current flows through RL load and it is ensured by the large reactance in series with the load and the freewheeling diode clamping it. A sinusoidal current flows through the resonance LC circuit to charges up the plate of the capacitor C with the upper plate as negative at the end of the half cycle. This current will then reverse and flow through the SCR in opposition to the load current for a small fraction of the negative swing till the total current through the SCR becomes 0. The SCR will turn off when the resonant circuit means reverse current is just greater than the load current. The SCR is turned off if the SCR remains reverse biased means TC greater than T off and the rate of pulse of the reapplied voltage is less than the rated value. So in this circuit, in class B circuit, class B commutation is self-commutated by an LC circuit. So the capacitor C charges up in the dot as positive before a gate pulse is applied to the SCR. When we are giving the gate signal to the SCR, the capacitor will be charged. When SCR is triggered, the resulting current has two components. So that components are the constant load current I load flows through RL load. So the constant current is ensured by the large reactance in series with the load and the freewheeling diode clamping. In a sinusoidal current flows through the resonant LC circuit to charge up capacitance with the dot as negative at the end of the half cycle. So here, so it is the dot at the capacitor, that is the upper plate of the capacitor, and the constant load current flows through RL load. The constant current is ensured by the large reactance in series with the load and the freewheeling diode clamping it. A sinusoidal current flows through the resonant LC circuit to charge up capacitors with the dot as negative at the end of the half cycle. So here this is the diagram for class B commutation, and here are the positive and negative terminal, and here are the one SCR. The SCR will be connected with the L and C, and also it is the diode of the freewheeling diode. The current will be biasing through the freewheeling diode, and L R is the load, and here is the waveform of gate current, load current, and thyristor current and thyristor voltage waveforms. Here this current will then reverse and flow through the SCR in opposition to the load current for a small fraction of negative swing till the total current through the SCR becomes 0. So the current will flow when the SCR becomes 0. The SCR will turn off when the resonant circuits, means reverse current, is just greater than the load current. So SCR will turn off, means it will be turned off where the resonant circuits, means reverse current, is just greater than the load current. So the SCR is turned off if the SCR remains reverse biased for TQ greater than T off, means TQ means here turn off time and and the rate of rise of reapplied voltage less than the rated value. So here this is the about class B commutation. Now we can watch the YouTube video regarding class B commutation.
Current commutation. So before starting current commutation, I told you that you should watch lecture number 6. There I derived the IL of T, that is equal to ICP sine omega naught T, where ICP is Vs under root C by L. This is the discharging LC circuit current equation, and omega naught is equal to 1 by under root LC. So I told you should go through the lecture number 6, then only proceed to this lecture, that is the current commutation. Okay, now we know that to turn off the SCR, we can turn on the SCR by supplying gate current, right? But to turn off the SCR, there is two methods. First method is either you can make the voltage polarity across this SCR negative, means this is anode, this is cathode. If I will make the voltage polarity across this SCR like this, Suppose I am connecting the capacitor such that the voltage across capacitor is like this, then this SCR will be in turn off state because it will go into the reverse blocking mode. You can see that negative is connected with anode and positive is connected with cathode. So this will go into the reverse blocking mode and it will turn off. SCR will turn off. This is one method. Second method is to turn off the SCR. Let us say I am supplying the gate current, means it is conducting, and let us say the current is flowing like this I0. Okay, now to turn off this SCR, what I can do is, if I will supply the current, let us say this is current I1, if I will supply the current I1 equal to I0 in reverse direction, then overall the current flowing in this SCR will be 0, means anode current will become 0, that is less than the holding current. In this way we can turn off the SCR. So two method of turning off the SCR. First one is the make the voltage polarity across the SCR such that it will go into the reverse blocking mode, and second, flow the current opposite to the initial current I0 such that I1 is equal to I0, then only it will turn off, means overall the current will become 0 and it will be turned off. Got it? So these two technique we will apply in force commutation. Now let us start the class B commutation, that is the current commutation. Okay, so let us move to the first slide. This is the circuit diagram of current commutation, the first one. This is the circuit diagram of current commutation. Here main thyristor is this, Tm is the main thyristor and Ta is the auxiliary thyristor which helps in commutation. So let us understand one by one. There are three modes in this type of commutation circuit. Mode 1 is from here to here, this is the mode 1. Okay, let us say the time taken is t1, and mode 2 is from here to here, so mode 2 time is t2, let us say. Okay, and I am assuming that I0 is constant. Here load current I0 is constant. This is the assumption. First assumption is I0 is constant, means the load is highly inductive. Okay, second assumption is the capacitor is charged up to Vs. Vc of t at t is equal to 0 is equal to supply voltage. The capacitor is charged up to Vs, and the polarity of voltage across capacitor initially is like this, from plus to minus. These are the second assumption. And third assumption is Tm is on for t less than 0, means this thyristor, main thyristor, is conducting for t less than 0 and capacitor is charged up to supply voltage, and the polarity of supply voltage is like this, from plus to minus. These three are the assumption. Now here I0 is constant. You can see in the waveform this is I0. Okay, this I0 is constant and it is ripple free. So this circuit is operating in three modes. Mode 1 starts from 0 to t1, mode 2 starts for t2 duration, and mode 3 starts from here to here. So we will see one by one each mode. So let us start with the mode 1. This is the mode 1. So what I am doing in mode 1, in mode 1 Ta thyristor I am triggering at t is equal to 0. You can see that Ta is on at t is equal to 0. See the waveform, Ta is on at t is equal to 0. So I am triggering this thyristor Ta at t is equal to 0. Then what will happen? The voltage across capacitor is like this. So the moment when you will trigger this thyristor Ta, means it will be shorted. Ta will be shorted like this. This is mode 1, and this capacitor will discharge like this, and the current flowing in this circuit, LC circuit, will be like this. Now see here, capacitor current, the direction, the actual direction is from left to right. It is flowing like this, but I have assumed that capacitor current is flowing like this. This is the assumption. I have assumed that IC is flowing from left to right, but when you will trigger this thyristor Ta, then the current will flow opposite to this IC. Then what will be the equation of IC of t? The IC of t will be minus of ICP sine omega naught t. This I have explained you in lecture number 6 how this equation is coming. I have assumed IC anti-clockwise direction, but in actual case the IC current will, the current flowing in this discharging LC circuit will be clockwise. That's why I can write IC. This is IC of t. So IC of t can be written as minus ICP sine omega naught t. Right, this is discharging LC circuit. So when TA will be on, then I will get the equation of IC of t is equal to minus ICP sine omega t, means capacitor will deliver energy to this inductor, and again this inductor will deliver energy to this capacitor, and this capacitor is charged opposite to the initial voltage polarity. Now this capacitor will charge after mode 1 like this, from plus to minus. Initially capacitor will deliver power to this inductor. Again when this inductor is behaving like a current source, then this inductor will deliver its energy to capacitor, means the capacitor will charge like this, from plus to minus, opposite to the initial polarity. Got it? So see here, when mode 1 will start, means at t is equal to 0, this thyristor TA will be on. So equation of ICT I will get, that is equal to ICP sine omega naught t, that can be written as Vs under root C by L sine omega naught t. This will be in minus. So ICP I will get something like this. This is the capacitor current, ICP sine omega naught t. It will be like this. Okay. At the same time the capacitor voltage will decrease, means the capacitor is delivering energy to this inductor. So capacitor voltage will decrease. So capacitor voltage will decrease like this. It will reach to 0 like this, and again inductor will deliver its energy to the capacitor, and the polarity of capacitor, the voltage across capacitor will be like this, from plus to minus. So capacitor will discharge first and again charge with opposite polarity. So capacitor, the voltage across capacitor will discharge like this, and it will again charge with reverse polarity up to minus of Vs. This is the minus of Vs. Got it? So when thyristor TA will be triggered, then the capacitor current equation will be ICP sine omega naught t, like this. It will be like this, sinusoidal from 0 to pi, and at the same time the capacitor voltage will discharge, and again it will charge with reverse polarity from minus to plus, like this. Means at the end of mode 1, what will be the voltage across capacitor? The voltage across capacitor will be minus Vs. This is the ending part of mode 1. Mode 1 will be from 0 to T1 only. Okay, so T1 duration, for T1 duration the capacitor current will be like this, and the capacitor voltage will be dropped from plus Vs to minus Vs, and it will reach to minus Vs. Got it? Now if I will ask you, what is the maximum current flowing in auxiliary thyristor TA? What is the maximum current flowing in auxiliary thyristor TA? So what will be the ITA max? The maximum current is flowing through this thyristor, auxiliary thyristor, will be ICP only. We have seen the current equation, ICP, that is equal to Vs under root C by L. I will take mode because thyristor won't allow the reverse current. I am assuming IC current is flowing like this, that's why the current I am getting negative, but in actual scenario the current is flowing in clockwise direction. Okay, so ITA max will come out to be ICP, that is equal to Vs under root C by L. This point you have to remember. In mode 1 the maximum current flowing in auxiliary thyristor will be ICP, that is equal to Vs under root C by L. Okay, now see the mode 2. See here, at the end of mode 1, what is the current flowing in the capacitor? The current flowing in the capacitor, the mode 1 starts from 0 to pi. So at the end of mode 1 the current flowing across capacitor will be 0, and what is the voltage drop across this capacitor? The voltage drop across this capacitor will be minus Vs, that we have seen in the previous slide, like this. This will be minus Vs, means the polarity of voltage across capacitor will be from minus to plus. Initially it was from plus to minus, but after mode 1 the voltage polarity across capacitor will be from minus to plus, like this. Now see in mode 2 what is happening. In mode 2 this diode will go into the forward bias. See, the voltage drop across capacitor will be from minus to plus. So here diode is connected. Okay, so this diode will be in forward bias because of this voltage polarity across the capacitor. Okay, so see here the anode is connected with plus, and cathode, this thyristor is conducting, so cathode is connected with minus. So this diode starts conducting in mode 2 and it will be shorted. Okay, so the moment when this diode will start conducting, this capacitor will again discharge from L as well as this diode as well as this thyristor. So you can see that the current across this thyristor because of this capacitor is from right to left, that is opposite to the main current. Okay, so in mode 2 what is happening, again this capacitor will discharge from L diode and this SCR, main SCR, in anti-clockwise direction, and again this capacitor will discharge and it will give the energy to this inductor. So what will be the capacitor current IC of t in second mode? IC of t in second mode will be ICP sin omega t, and here ICP sin omega t will be positive because initially the IC current polarity I have taken like this and the current is also flowing like this, that is anti-clockwise direction. So IC of t I will get ICP sin omega t. So current equation after pi will follow the sinusoidal behavior like this and it will flow opposite to the Im, that is the main current, means it is opposing the main current, so it is nullifying the main current. Okay, and we can see that at omega t is equal to pi, the main current is I naught. Okay, so the moment this IC of t will be equal to I naught, that is equal to main current. Okay, so the moment when IC of t, that is ICP sin omega t, will be equal to main current, then this overall, the current flowing in this thyristor overall will be equal to 0 and this thyristor will go into the off state. So we can see that after pi, the current, the capacitor current will increase sinusoidal as well as the main current will decrease because the capacitor current is flowing opposite to the main current. Okay, so it will decrease the overall current flowing in thyristor Tm, that is the main thyristor. Okay, so the moment when ICT will be equal to I naught, or I can say that Im, then at that time the thyristor Tm will be off because anode current at that time will be 0. So you can see that capacitor current is increasing sinusoidally like this and main current Im is decreasing like this, and the moment when Im will be equal to 0, Im will be equal to 0, that is equal to anode current only na. So the moment when Im will be 0, this thyristor will be in off state, here anode current is 0 and capacitor voltage is minus VR, so it will go into the off state. Are you getting me? So in this way, these commutating element, main auxiliary thyristor, capacitor, inductor and diode, this is the circuit na, this is the commutation circuit. So this commutation circuit will force the SCR to go into the off state by supplying the current opposite to the main current such that the anode current across the thyristor will become 0. In this way mode 2 works. So at the end of mode 2, if I will ask you what is the voltage across this capacitor, the voltage across this capacitor will be minus VR, and at the end of mode 2 what will be the main thyristor current? The main thyristor current will be 0. You can see that this is the ending of mode 2 na, this is mode 2. So at the end of mode 2 the main current will be 0, and at the end of mode 2 if I will ask you what is the current, the capacitor current will be maximum current, that is equal to I naught. Now I define the mode 1 time this time as T1 and mode 2 time as T2. Now suppose I will ask you what is the voltage across this capacitor at the end of mode 2. So voltage across this capacitor at the end of mode 2 is nothing but minus VR only. You can see that at the end of mode 2 the voltage drop across this capacitor will be minus VR. So how can I find Vc of t? See, Vc of t we have already found in the lecture number 6. The Vc of t is nothing but Vs cos omega t. For discharging LC circuit, Vc of t is equal to Vs cos omega t. You can see this equation in lecture number C. Okay, so at the end of mode 2 what is the total time? At the end of mode 2 I can say that this is the total time. Okay, and this is pi and this is T2, right? So I can write total time like pi plus omega T2. Okay, this is the total time at this point. Okay, so I can write like this: Vs cos pi plus omega t2 will be equal to minus VR. I can write like this. See, this is Vs cosine wave, right? So Vs cos pi plus omega t2. This is pi and this is omega t2 in degree. So pi plus omega t2 will give the capacitor voltage across this point pi plus omega t2. So at pi plus omega t2 the capacitor voltage is minus VR. So I can write like this. That will be equal to Vs cos pi plus omega t2 is equal to minus VR. So VR will come out to be minus Vs cos pi plus omega t2. Okay. Now in order to find the t2 is the time, this is the t2 na. So t2 I can write ICP sine omega t2 is equal to I naught. See, the current, capacitor current increases from 0 to I naught in the range t2, and this capacitor current equation is ICP sine omega t2 is equal to I naught in the range t2. So from this equation we can find omega t2. Omega t2 will come out to be sine inverse I naught upon ICP, where ICP is the Vs under root C by L that we have discussed in lecture number 6. So T2 will come out to be 1 upon omega, that is under root LC sine inverse I naught upon ICP. We can find T2 from this equation. Now replace omega T2 from VR. So VR will come out to be C cos pi plus theta is minus cos theta. So it will be plus Vs cos omega T2. Omega T2 I can write sine inverse I naught upon ICP. Remember this voltage. What they will ask you? They will ask you at the end of mode 2 what will be the voltage drop across the capacitor. So the voltage drop across capacitor will be Vs cos sine inverse I naught upon ICP. And what will be the time t2? The time t2 will be 1 by omega sine inverse I naught upon ICP, and omega can be written like under root LC sine inverse I naught upon ICP. These 2 points you have to keep in mind at the end of mode 2. What is the voltage across capacitor and what is the current flowing in capacitor. So at the end of mode 2 the current flowing in capacitor will be equal to I naught and the voltage drop across capacitor will be equal to minus VR. So it will come out to be Vs cos sine inverse I naught upon ICP. So at the end of mode 2 this main thyristor is off. See here, at the end of mode 2 what is the current flowing in main thyristor? The current flowing in main thyristor will be 0 and the voltage across the main thyristor is minus VR. So overall this main thyristor will be in off state, and in mode 3 what will happen? This supply voltage will again charge the capacitor up to Vs. This supply voltage will again charge the capacitor up to Vs, and after that it will be open circuited. So you can see that after mode 2 main thyristor will be in off, Tm is off, and this capacitor voltage will again charge up to Vs. This is the plus Vs, okay, by supply voltage, and after that it will be in off state. Got it? Similarly the capacitor current you will get that is equal to I naught from this. This is the I naught, right? So here the capacitor current you will get that is equal to I naught. That is the end of mode 3. So if I'll have to explain all the 3 modes, then how will I explain? See, in mode 1 what I am doing, I am triggering this thyristor TA. I am triggering this thyristor at TA at T is equal to 0. So this capacitor will discharge, again charge the inductor. Now this inductor will discharge and it will charge the capacitor, and the polarity of voltage across capacitor at the end of mode 1 will be from minus to plus like this. And the waveform I will get like this. The capacitor current will be minus ICP sine omega naught t up to pi, and capacitor voltage will be cosine wave that will decay like this Vs cos omega naught t, and it will again charge to minus Vs, and the polarity will be like this. That is the end of mode 1. Now what is happening in mode 2? In mode 2 the voltage drop across this capacitor is from plus to minus. It is like this. So this auxiliary thyristor will go into the off state because of this reverse voltage drop across this capacitor. Okay, so this thyristor auxiliary thyristor will be off at the end of mode 1, and after that this diode will get active because the polarity of voltage drop across this capacitor is from minus to plus. So this diode will be go into the forward bias and it will be sorted. So now the current, the capacitor current will flow opposite to the main thyristor current. Initially the main thyristor current is flowing I naught. So the moment when this capacitor current will be equal to I naught, then the overall the current across this thyristor will be 0, anode current will be 0. So when ICP sine omega t is equal to I naught, then this overall the current across this main thyristor will be 0, anode current will be 0, or you can say that main current, the main thyristor current will be 0, and at that time the thyristor will go into the off state, because at that time the anode current is 0 as well as the voltage drop across this main SCR is negative. It is from like this, minus to plus, that is equal to VR, minus VR. Got it? This is the mode 2. And what is happening in mode 3? In mode 3, main thyristor is already in off state, so supply voltage is charging the capacitor like normal, and the current, the capacitor current will be equal to I naught, that we have seen in mode 3. Okay, so in mode 3 the capacitor will again charge from minus VR to plus Vs, and the polarity will be like this. Okay, and it will be open circuit. That is the end of mode 3. Now if I'll ask you what is the circuit turn off time. So what is the circuit turn off time? Circuit turn off time is defined as the time for which this main thyristor, main SCR is in reverse bias. Okay, so for how much time this main thyristor will be in reverse bias? See, this is main thyristor, right? And this thyristor is getting off when the voltage drop across this capacitor is minus VR, like this. Okay, so circuit turn off time is defined as the time for which main thyristor is in reverse bias. So this thyristor will be in reverse bias till this capacitor voltage drop from minus VR to 0. When this capacitor voltage drop from minus VR to 0, till then only this main thyristor, the voltage drop across the main thyristor will be negative, and circuit turn off time is defined as the time for which this thyristor is in reverse bias. For how much time this thyristor will be in reverse bias? When the voltage drop across this capacitor will be negative, for that time the thyristor, main thyristor will be in reverse bias. Is it fine? So main thyristor is reverse bias from minus VR to 0. After that the voltage drop across this capacitor will be from plus to minus. In this case the thyristor will go into the forward blocking mode, not the forward conducting mode. The thyristor will go into the forward blocking mode when the voltage polarity of across this capacitor will be from plus to minus. Okay, so forward we will not include the circuit turn off time in forward blocking mode. We will see only the reverse blocking mode. So reverse blocking mode I will get when the voltage across capacitor will be negative, means minus VR to 0. Is it fine? So I am getting the voltage drop across this capacitor from minus VR to 0. So this is the circuit turn off time. Got it? This is the TCM. So how will I find TCM? We know that Vc is equal to 1 upon C integration of I dt. Okay, now integrate both sides from minus VR. When this capacitor voltage will go from minus VR to 0, then I will get the circuit turn off time 0 to TCM. So circuit turn off time will come out to be CVR upon I naught. Okay, this IT is nothing but I naught. See here, this IT is equal to I naught. So TCM will come out to be CVR upon I naught, where VR we have already found. VR is equal to voltage drop across the capacitor at the end of mode 2. Okay, so let us summarize the formula that we have derived. First formula is what is the current flowing in the main thyristor, peak current flowing in the main thyristor. See, the peak current flowing in the main thyristor is nothing but the load current only. We have seen the peak current here. In mode 1 it is I naught. Okay, in mode 2 it is less than I naught, because capacitor current will decrease the main current, so it will be less than I naught. So peak current across the main thyristor will be I naught, that is equal to load current. Okay, now what will be the ITA peak? We have already found ITA peak. This is the main auxiliary thyristor current na. So peak current across the auxiliary thyristor will be ICP. We have already found, that is equal to Vs under root C by L. So peak current across auxiliary thyristor will be ICP, that is equal to Vs under root C by L. Okay, what is the conduction time of TA? See in the waveform, thyristor TA is on at t is equal to 0. and it is getting off at T is equal to T1. So conduction time of auxiliary thyristor will be from here to here. This is 0 and this is T1. See here, TA is on at T is equal to 0 and TA is getting off at T is equal to T1. So conduction time of thyristor TA will be equal to T1. Okay, so we can find T1. T1 is this much only and it is at pi. So I can write omega T1 is equal to pi. So T1 will come out to be pi by omega, that is equal to pi under root LC. So T1 will be equal to pi under root LC. Got it? Now the fourth point is time required to turn off main thyristor after TA is on. See what they are asking? They are asking time required to turn off the main thyristor after TA is on. TA is on at T is equal to 0. We can see by graph. TA is on at T is equal to 0 and main thyristor is getting off here. This is the turn off time. Total turn off time of main thyristor will be this much after TA is on. So after TA is on at T is equal to 0. What is the total time taken by main thyristor to turn off? That is equal to T1 plus T2. This is T1. We have already discussed this is T1 and this is T2. So overall total time will be T1 plus T2. And we have already found T1 as well as T2. T2 what we are getting? We are getting T2 is equal to under root LC sin inverse I naught upon ICP. We have already found this equation. Okay. So time required to turn off TM after TA is on, that is equal to T1 plus T2. Now the fifth point is minimum time required to turn off TM after TA is on. So what will be the minimum time required to turn off the main thyristor after TA is on? See, TA is on at T is equal to 0. Okay, and this is the minimum time required after TA is on. This is the minimum time, that is equal to T1 only. How? Let us say load current is very small. Let us say I naught is very small. So when I naught will be very small means I naught will be somehow like this. Okay, so minimum time after mode 1 it will decrease like this, and this will be the minimum time required to turn off the main thyristor after TA is on. This is the minimum time. So when load current will be very small, then we can say that minimum time required to turn off the TM after TA is on, that is equal to T1 only. See, after T1 it is the main thyristor current is decreasing quickly. So we can say that minimum time required to turn off the main thyristor, that is equal to T1 when I naught will be very small. This is the condition. Okay, so when I naught will be very small, then minimum time required to turn off TM after TA is on, that is equal to T1, that is equal to pi under root LC. Okay. Sixth point is capacitor voltage at the end of second mode. We have already found at the end of second mode. This is the end of second mode, right? So at the end of second mode, what is the voltage drop across capacitor? The voltage drop across capacitor is minus VR. So at the end of second mode, the voltage drop across capacitor will be VR, that is equal to minus Vs cos sin inverse I naught upon ICP, that we have already found. Now the seventh point is circuit turn off time of TM. So we have already found that is equal to CVR upon I naught. Circuit turn off time is defined as time for which thyristor is in reverse bias. So thyristor is in reverse bias when the voltage drop across capacitor will be negative. So voltage drop across capacitor will be negative from minus VR to 0. So we can find the circuit turn off time like this, that is equal to CVR upon I naught. So these all formula you have to keep in mind, because most of the question can be framed from this formula only. Till now none of the question has been asked from the class B commutation, that is the current commutation in GATE exam, but still you have to remember this formula. For derivation how this formula is coming, we have already.
So now we watched the YouTube video for class B commutation. Now summary. Today we learned the circuit diagram of class B commutation techniques and working of class B commutation techniques, and here we have the few quiz questions and frequently asked questions. This is the class of class B commutation, and next class we are going to discuss about the class C and class D commutation. Thank you.